Okay, I am in record mode. So, I might be a little sporadic in how I approach these. What did I say? Find the derivative of each function, simplify according to standards established in the classroom. Well, that directive is out the door since we don't simplify anymore. Hand in all materials in a manner similar to the summer assignment, which you guys didn't have. Rewrite on other paper and show neatness. Okay, so here we go. I think you're going to find a nice variety of derivatives. I challenge you to do these in one step if you can. I'm going to try to do likewise. I'm not going to be able to preserve an answer key because I'm going to be doing this on my pen mode. And when I go into pen mode, I can do all my writing. But when I come out of pen mode, all the writing, at least as far as I know how to do it, all the writing gets lost. So, okay, as fast as I can, number 1 and 2, as fast as you can say it, you should be writing it. That's a quotient rule. Bottom times derivative of the top minus the top times the derivative of the bottom over the bottom squared. Done. Okay. All right, number 2, maybe you want to write it in a radical form first. It is in radical form. Maybe it's easier if you write it as a 3x squared minus x plus 1 to the 1/2. However you write it, you should end up with this. Okay. Number 2 and that's 1 and 2. How about 3 and 4? You know what? I think I can do 3, 4, 5, and 6 in one pen mode session. Let me try to do that. I'm going to do 3 and 4 above the written equations, and I'll do 5 and 6 below. I'm going to try not to talk so that you guys are doing this on your own. These are the kinds of questions that when we finally get together and I can give you a derivatives quiz, these should be, I think these are fair questions as far as the difficulty. If you want extra radicals, talk to Aiden. Otherwise, I think that these are fair questions. I mean, the College Board, they do enough things to trip you up, but on balance, I think the integrals and the derivatives they give you, I think, are fair. So anyway, stop talking, Dan, and just do some derivatives. I haven't gone through and checked any of these. These are just pretty much just read them, apply the rule, and write. I'm going to double check now. Number 3 is a power rule. Something to the third becomes that something. We've got 3 times that something to the second. There's the application of the power rule. The chain rule is then the derivative of what's inside that something, which is 3 minus 4x. I'm liking number 3. Number 4 is a quotient rule. Bottom times the derivative of the top, which I guess you wouldn't necessarily have to write that because since the top is a constant, we've got a 0 there. The derivative of -7 is 0. So bottom times the derivative of the top looks good. Minus the top, notice we got minus a -7 times the derivative of the bottom. Well, the derivative of the bottom is kind of like the one we just did for number 3. You apply the power rule, 2 times that 3x minus 1 to the first, and then you got to chain rule the contents of that 2x minus 3, so get times 2. There's the chain rule. And you do all that work on the numerator. Don't forget that you got to square the denominator. 2x minus 3 quantity squared, and then you square that. Obviously, if this were a multiple choice question, you would never see it written like that. Number 5 looks like a product rule. First times the derivative of the second plus the second times the derivative of the first. Okay, here's the first, just rewritten. The derivative of the second is, we've got a radical, so this is 1 minus x squared to the 1/2 power. So here's the power rule being applied, 1/2 times that 1 minus x squared to the negative 1/2. There's the power rule. And then we got to take the derivative of the inside, which would be negative 2x. That's the first part of the product rule. First times the derivative of the second. Now, the second part of the product rule is you take, this is the easy part for this question, is the second times the derivative of the first. And I don't see any errors in that. I'm liking number 5. And for number 6, it looks like we've got ourselves a quotient rule here. Bottom times derivative of the top. Okay, there's the bottom. Derivative of the top, it's x, so the derivative of the top is 1. On the quotient rule, continuing, okay, it's bottom derivative of the top minus the top derivative of the bottom. That's just a mess. It's x plus 1 to the 1/3 power. So applying the power rule, we've got 1/3 times that quantity that's inside that radical to the 1/3 minus 1. So that would be to the negative 2/3. And then chain rule does ask us to take the derivative of what's inside, which is simply 1. And then finally, don't forget that you've got to square the denominator. So we've got that cubed root of x plus 1, and then we're squaring it. Okay, I'm liking 3, 4, 5, and 6. If you guys have any questions or if I made an oversight, I'd appreciate it if you let me know. Again, my answer key is in the building. I was going to say my answer key's at home. Sometimes it feels like I live there, but anyway, let's see, 3, 4, 5, 6. Now we've got, okay, 7, 8, 9, and 10. Hey, what else are you going to do on a snowy day, snowy Thursday? Just get it. I got my cup of coffee right here, easy chair, taking derivatives. Go. 7, 8, 9, 10. I will try my best not to talk. All right, I can't help myself. I have to talk. This question that I just did, number 7, I think I got it right, is not, I think that is beyond difficulty as far as a quiz goes. I think if this were an assignment that I mean, back in the day when I would give written assignments, I think this is a fair written assignment because I would give this to the class. You guys would work on it. You presumably and hopefully would work together. You'd check your answers. You'd have time to simplify, and on balance, this kind of a worksheet, usually everybody did really well on this. But the nature of these questions, I think they are more difficult than what I think should be on a quiz. So an editorial, in case you're having a panic moment thinking, oh my gosh, is this going to be on our next derivatives quiz? I think that number 7 is at the upper bounds of what I think is reasonable. So that means probably no. One of the things you learn as a parent is never speak in absolutes. Notice I did say probably. It's kind of like when your kids ask, "Can we have pizza for tonight for dinner?" It's like, we'll see. Don't want to ever break a promise to one of your kids. So, Now 8, this, oh my gosh, this is an easy one. Did I say I was going to stop talking? After number 7, 8, 9, and 10 were relatively easy, I believe. Number 8, derivative of the sine is the cosine, little chain rule added on. Number 9, I think one of the things about this one is this whole syntax of putting squareds in. Um, this on your calculator on the TI-84, I do not think you can write it like this. I think you have to take the tangent of x and parenthesize the entire quantity. Um, if you're not careful with your parentheses, you'll accidentally get the tangent of x squared. Those are two different functions, two different derivatives. So not doing this, proceeding as if the argument is the tangent that is wrapped around an expression of power, something squared. Okay, so we've got 2 times that something to the first, and then the derivative of what's inside, derivative of the tangent is the secant squared. 9 looks good. Number 10, how many of you did the product rule? Notice that we've got 2x plus 1 as the base, and then 2x plus 1 as a base again. We can rewrite this as 2x plus 1 to the 15th. If you missed that and you proceeded to do the product rule, that's fine. You'd have ended up, assuming you did everything correctly, you'd have the right answer. Just would be a little bit clunky. If you combine them into one, then you only have to, well, it's easier. We got something to the 15th, so it's 15 times that something to the 14th, and then chain rule the interior. So we got a factor of 2 to finish. And there is 7, 8, 9, and 10. I'm going to look at the clock here. How we doing? It's 10:35. This is officially the end of period 2. I'll tell you what, I'm going to grab a coffee as I'm going to clear screen, scroll up, and we'll try 11 through 14. I kind of themed up a little bit. It looked like I was in I don't know what kind of mood I was in for that. Okay, 11 through 14, I'm going to heat up some coffee. Less talking, more derivatives. We've got the derivative of the tangent is the secant squared, chain rule. For number 12, derivative of the cosine is the negative sine, chain rule. For number 13, we've got a product rule, or I'm sorry, a power rule on the outside. So 2 times that quantity to the first. And then we've got a chain rule. And then we've got another chain rule nested within. And then finally, number 14, just to rewrite, instead of cosine of that quantity 3x to the squared, I'm going to write it as a cosine of 9x squared. Derivative of the cosine is the negative sine of that quantity, and then chain rule. All right, questions? Okay, we're up to 14. I think this is the same question as number 14. This is me being clever when I write worksheets. This is what sort of mischief my brain gets me into. I think 16 is just rewrite that. I mean, if you want to nest those functions together and do, multiple layers of chain rule, knock yourself out, I would rewrite it as 2x plus 1 to the 15th. Y equals sine squared of x. And isn't the secant and cosine are reciprocals of each other? So 1 over cosecant squared, isn't that cosine squared? And that's the Pythagorean identity. So we've got y equals 1, which means y prime equals 0. This is a nice one, number 18. Okay. First of all, let's dispel any notions. Where'd it go? Where'd it go? There it goes. Y is not equal to the sine of 6x to the third. Don't be tempted to combine those. I would probably look at this as maybe a product rule, where this will be my first, and this will be my second. So for number 18, let's try it this way. Y prime is the first times the derivative of the second. Well, the derivative of the second is going to require a product rule. So just zeroing in on the derivative of that second. Okay, it'll be the sine of 2x times the cosine of 3x times 3 plus the sine of 3x times the cosine of 2x times 2. Okay, that is, hold on, let me just take some stock here. This is the first times the derivative of the second. Okay, now we got to add to that the second times the derivative of the first, which is the easy part. The hard part is remembering which shade of green I picked. So that'll be plus sine of 2x sine of 3x times the derivative of the first, which would be the cosine of x. So just so that'd be plus, there's the v, and this is the u prime. All right. And for the record, I think that's just me being tricky. I think that's the kind of question I would write on a take-home assignment, so you'd have time to organize. I mean, I think one of my philosophy, I don't give a lot of tests and quizzes, you guys know that, not especially not this year, is I think that there should be a when you're taking something under the stress of time and pressure and working by yourself and whatever memory you have, what you recall, I think that's the time when the question should be the most basic. Show me what you know. If the more time you have, the more resources you have, I believe the question should increase in difficulty. And to that end, I think number 18 is one that I think that's borderline not fair for, I would say, even an AP calculus class. I think that's just a teacher trying to be tricky if it were a quiz. If it's take home work, I think it's a fair question. All right. So we're talking hypothetical. Maybe next year's class will get that. So anyway, I'm rambling. Our time is running out. And is that it? Last two questions, 8, 19, and 20. Okay, let's sort of walk through these, see how we did. Actually, I see how we did. I'm going to walk through them, see if my thought process is sound. Okay, we've got the tangent of something. The derivative of the tangent is the secant squared of that something. The chain rule of that argument, derivative of the cosine is, derivative of the sine is the cosine. I'm liking that. Number 20, I got those two uh, powers, these two squarings going on. I think this is a case where taking the time to actually rewrite it makes it a little bit more clear that the outer function is a power rule. We're taking something and squaring it. That's on the outside, so we're going to do that and represent it as 2 times that something to the first power. And now we have to look into that argument of that squaring, and we see the cosine of x squared. Okay, well, the cosine is the outer of those two, and the x squared is inside it, so to speak. So the derivative of the cosine is the negative sine of that x squared. And then finally, the last stage is we got to take that x squared and chain rule it again to 2x. And I believe that's the unsimplified, but I believe that's the derivative of number 20. Okay, 1 through 20, I did tape them. I'll probably watch it as I in preparation for posting it. I'll probably edit out my going to get coffee and the like. So by default, I'll end up watching what I did, and if I see any mistakes, I'll point them out. And if you guys see any mistakes, please let me know. I'm not intent. There are times when I intentionally make a mistake at the board. I did not make any intentional mistakes on any of these derivatives. All right. Okay. Here's the other thing. I'm in pen mode still. Get out of pen mode. I don't think we need this. Okay, let's go into here, this advanced Kentucky thing. I'm going to walk you through, again, this came from a Facebook group. I know nothing about advanced Kentucky. I'll show you what I navigated my way into. If you go here, that'll take you to this page. Upcoming events. If you go into here, I'm not sure I trust this schedule here. If you want content, I would go right here, math and computer science, and go to AP Calc. And what you have here is, and they're kind of all over the place. I'm not really sure. I think, well, here, let me tell you, I believe this is just a couple of high school teachers that are putting content up. Because I watched a part of this review session. It ran 2 hours, so that's kind of painful. But they have an AB. Notice at the top, this is an AB session. If you want the handouts, you click here. And I think this is a PowerPoint. Okay, then I think that, well, let me see. I click on here. Google Drive. You can see I opened these this morning, and the AB, when I opened it, looks like this. It's PowerPoint. Eventually, you'll get to a PowerPoint. And oh my gosh, where is it? There it is. And you can download, in fact, I did download this. Here is their PowerPoint downloaded from me. And there's a lot of like average versus instantaneous rates of change. I got to clean up my desktop. This is opening really slow. Yeah, basically this is average versus instantaneous rates of change. There's a grass clippings question. estimate the rate of change at W using a table of data. Here you're estimating rate of change using an equation. I believe you need a calculator for this. Again, you got to pick and choose what you want to spend time on. I have enrolled for one of these review sessions. I'm going to see what they're like. The other one that's available that I thought was more, I was just wanted to see where we are, was this BC content review. If you click here, what you'll get is you'll get this. Okay, this was, I think they did this earlier this month. And here are what they worked through. Let's see. If you want the walkthrough, this is the walkthrough right here. I'm just going to start it so you can see it.
Are they saying there's one message right now just says it's confusing on where to start, but then once they realize which method to use, it's okay? We know our starting value.
Okay, I'm not good. The audio is scratchy at best, especially watching it through me. It's just, I think it's just a high school teacher, and every now and then she kind of pokes her head in front of the screen. It starts off with a moderator at this high school. There's the moderator right there. I don't know. I think she introduces herself. And then the teacher that actually leads the instruction, she's right there. And you can see that the duration of this review is about 2 hours. Ugh. So I went through, and I think there are 2 questions that are worthy of spending a little bit of time on with what we have, because I wasn't sure how to do number 1. There's number 1. How would you integrate that? And if you want her walkthrough, go to the video I just showed you, and you can walk through it. I have never seen a question like this one. If you try U substitution, I think you'll hit a dead end. If you try an inverse tangent, I think you'll hit a dead end. And both of those attempts are represented by these options right here. In fact, the way you want to do this is through long division. So with the, let's see, we've got, I'm seeing about 10 minutes left. Normally, when you're doing a long division technique, what you're thinking about is a degree in the numerator is greater than or equal to the degree in the denominator. I'll tell you what, let's just trust the process here and say that long division will get you home. Yes, we are shifting from derivatives to integrals. That's part of the challenge. You know, I realize if you're a mechanic and your tools are all metric, you don't have to switch mid-job and go to English tools. But in calculus, you got to be able to juggle between going in one direction with a derivative and being able to turn on a dime and go the other direction with integration. You know, we've spent the last 45 minutes or so doing derivatives, and here we are doing a 180, trying to do integration. That's the nature of the beast. So to divide, we've got 1 plus e to the 2x divided by 1. Okay. Well, it's going to take 1 times 1 is going to get us 1. So what that would get us would be right here. We'd have 1 plus e to the 2x. We're going to take that quantity, we're going to subtract it. What that's going to leave us is a negative e to the 2x, which is our remainder. So what we end up with is the integral of 1 over 1 plus e to the 2x dx is equal to the integral of 1 minus, or you could, let me do it this way, 1 plus negative e to the 2x over 1 plus e to the 2x. Okay. So I don't know whether, I don't know what to do with that negative sign. How about we do this? Let's split this into two separate integrals. This is the integral dx minus the integral of e to the 2x over 1 plus e to the 2x dx. All right. Even though we got more stuff in it, we are now eligible to try a U substitution on this. What I'm leaning towards is a U substitution technique that's going to work us towards a natural log integral rule. All right. Make a little space. Our U is going to be 1 plus e to the 2x, or du dx is going to be e to the 2x times 2. Solving for dx. Now, the U substitution part, I'm going to hold off. We've got this integral dx is just going to have to wait a while. Minus the integral of e to the 2x over u times du over 2e to the 2x. Those guys cancel out. Now notice we're not substituting over here. We're not taking this dx and putting it over here. This is its own separate entity right now. If you don't separate that, then you technically would have to. It could just get messy. So let's just let it bide its time. We have the integral of dx minus 1/2 the integral of 1 over u du, which is going to be, again, I'm running out of room here. Let's get rid of all this. What we've got is x minus 1/2 the ln of u plus c, and u is this. So as I'm looking for answers, it's looking like option D is the winner. All right. And when you have a multiple choice question like this, if you were totally frozen on what technique to take, you could just take 4 derivatives and see which one gets you to that integral. Anyway, we're close enough to time. I'm going to call it here. One last thing you might see, I'll just talk to you guys direct on this. Stop share. All right. One of the things you're going to see in the Power School is I've created a assignment called Above and Beyond. I'd always done this in the past as an extra credit opportunity, and normally in the back and forth flow of conversation, it emerges much earlier than the 3rd marking period. Above and Beyond are things that you initiate, and they are above and beyond the course. They should be related to the course. And the open invitation for any of you guys is to do a one-time Above and Beyond where you contact somebody that has taken calculus at Cedar Cliff, or is taking or has taken calculus in college, or uses calculus on the job. Contact them. Please do not say, I need this for extra credit. I think that's crass and I won't count it. But what I want is you to courteously approach them, ask them about their calculus experience, and if they respond to you, forward that response to me, and that I would consider as an above and beyond. I've set these types of above and beyonds at 3 points, and you can do 1. All right. The total above and beyond is worth 10. So if you can find something extra that you feel is worthy and appropriate, see me in advance. I do not want a glittery poster showing up and say you want 10 points. I need to see it in advance. We need to I need to, not because I'm a control freak, it's just I want to manage expectations. I want to make sure it's not something more than is necessary. I don't want to have false expectations about how much it's worth. So please see me in advance. It's a little something worth up to 10 points added to your total of the course. It's not going to boost your grade 10 points. It's going to be like, I think by the end of the marking period, you'll have 400 to 500 points. So if you max out with all 10, that might be 1 or 2%, depending on how things round off. All right. I am close enough at time. I'm going to call it here. I'll see you tomorrow as we finish up our abstract applications of integration. All right. Thanks all for your attention. Have a great day. Lift with your legs, not with your back. Bye.